Hello, everybody, and welcome to We Measure the World, a podcast produced by scientists for scientists.
So through this project, we are not only trying to see how irrigation and soil compaction affect potato yield, quality, and soil moisture availability, but we are also trying to understand how soil compaction and irrigation are correlated and how their interactive effect can affect those factors. If you ask me a one-liner, definitely I would say that we are working to optimize soil and water management so that soil could store more water and we could make best utilize of available water.
That's just a small taste of what we have in store for you today. We Measure the World explores interesting environmental research trends, how scientists are solving research issues, and what tools are helping them better understand measurements across the entire soil-plant atmosphere continuum. Today's guest is Isha Chand. Isha completed her bachelor's in agriculture from Trivavan University in Nepal, where she developed an interest in environmental plant interactions and soil hydrological properties. To expand her knowledge, she joined Washington State University's Soil Science Master's Program in 2025. Her current research focuses on understanding the nexus between soil health, soil moisture, and irrigation management for potato production in Northwestern Washington. And today she's here to talk to us about how irrigation management and soil compaction impact potato yield. Isha, thanks so much for being here.
Thanks for inviting me. It's my pleasure to be here.
So we love to start with our guest about asking them about their background and what got them into science in general and what got them into their specialty. So what brought you into soil water research and then, I guess, potatoes in Northwestern Washington?
It's a really interesting journey for me. I completed my bachelor's in agriculture from Nepal, my home country. And during my undergrad, as a mandatory course, I need to conduct a research. And I was focusing on mitigating water stress through osmotic and hormonal priming. I think that experience definitely helped me spark my interest in understanding soil water plant relations. And as I was going deeper into it, I was further fascinated by the correlated ideas of abiotic stress, stress physiology, and soil hydrology. More importantly, I think it helped me to recognize my interests and how much I enjoy connecting scientific queries with research, observation, and real world implications. Then I decided to look for the opportunities for masters, and fortunately, I came across this project, which completely revolves around my interest area. Earlier, my experience were more exposed to crop, waters, but this also integrates the idea of soil health, which was really interesting and was adding a new dimension. At that very point, I realized this opportunity is like golden opportunity for me to dive deeper into the area where I'm truly passionate about. Today, if you ask me, I'm loving my work and I can do this similar work for years and years. Yeah, this is how I end up being in this specific area of science.
Excellent. So was there a specific moment, I don't know, like in a field season or a class that really hooked you and said, yes, this is what I want to do with my studies, with my research, with my career?
To be honest, when I was doing my undergrad, I was looking for stress, and the thing is that we have limited amount of equipments, and I was looking for sensors, and I didn't have that facilities and things there. I think that one point make me realize I should go for better opportunities, and I am really interested in research. I can study. If you tell me to study about water stress and soil physical health for a longer period of time, I can spend hours in my laptop reading those things. So I think that helped me trigger that, okay, I need to study in good environment where I have all equipments, all facilities, and I want to study this course for sure. So I think giving 2 years to this project and my master's wasn't a big decision.
Mhm.
So yeah.
And with your current research into potato yield and the impacts of soil compaction and irrigation management and other things, can you explain a little bit or go into a little bit of detail about the background of this project, like how it got started and where that came from?
Our project managing soil moisture and soil physical health for fresh market potatoes in Northwestern Washington. As you say earlier, we are trying to understand the nexus between soil physical health, soil moisture, and irrigation requirement for crops. If you look at Maritime Pacific Northwest, managing irrigation water is really challenging. There is an increasing competition for water resources between agriculture, municipal, and domestic uses. At the same time, climate change is also expected to reduce the growing season precipitation and increase the agricultural use by approximately 10% in this region. I think this all illustrate how challenging irrigation here it is, and it also helps illustrate the need to optimize the water uses. On other hand, the concern was the variability that exists in interannual precipitation patterns. For instance, the first year of our study, 2024, we received the growing season precipitation was almost double as compared to 2025 growing season. And if you see the long term trend, also, you can feel the variability that exists, which also introduce the factor of unpredictability in irrigation scheduling. Another big concern that we are looking for is soil compaction. The repeated tillage activities, the intensive tillage always deteriorate the soil, and it may also induce surface as well as subsurface compaction. These things make it harder for root to go deeper and also reduce the water holding capacity, which may subsequently increase the irrigation requirement for crop. It might be surprising, but soil compaction and its effect in water storage is reported by farmers as two of the most pressing soil health hazards or health issues. So, one other point that I would definitely love to add in is that as I'm working in potatoes and potato system, there are practices like rototilling, hilling, and vine killing, whereas the series of pesticide application, due to which the soil is exposed to heavy equipments and intensive tillages, which make the soil more susceptible to soil compaction. At the same time, Northwestern Washington is home to high value crops, including potatoes, and approximately 10,000 to 11,000 acres of land is grown in potatoes. And if you see the data today, 100% of those receive supplemental irrigation. That shows the essence of irrigation. So through this project, we are not only trying to see how irrigation and soil compaction affect potato yield, quality, and soil moisture availability, but we are also trying to understand how soil compaction and irrigation are correlated and how their interactive effect can affect those factors. If you ask me a one liner, definitely I would say that we are working to optimize soil and water management so that soil could store more water and we could make best utilize of available water.
So, who are your key collaborators on this project?
So in this project, we have lots of collaborators. The PI of the project is Dr. Gabriel Lehue. He is an associate professor at Washington State University, and this project is funded by Washington State Department of Agriculture through Specialty Crop Block Grant Program. And along with the soil people who are in the team, there are pathologists, there are economists, as well as we also work with farmers who are the stakeholders, and definitely they are helping us a lot to understand how the local potato cultivation goes here.
Let's get into study design for this project. I think there's a lot of interesting things that we haven't really discussed on this podcast. One of those that I'd like for you to explain for our audience is the term management allowable depletion, MAD or MAD. I don't know how you like to say it in practice, but can you briefly explain what that is? So again, management allowable depletion.
I think I should bring some other terms that will help us to understand what is management allowable depletion. So basically, the difference between fill capacity and permanent wilting point is called available water range. So fill capacity is a condition where all your gravitational water is lost. For instance, after rainfall, after 2-3 days, you will receive that fill capacity. And permanent wilting point is a point where plant don't have any access to the water. There is no water. There is only the water around the soil particle that is not accessible to plants. So basically, the difference between fill capacity and permanent wilting point is the plant available water. And I have different labels in my experiment. For instance, 25% management allowable depletion. So that means you have 75% of plant available water still remaining in the soil. So similarly for other label, I have 50% MAD, which means you have 50% plant available water still in the soil. So I hope I could explain it well.
Okay. So basically it's the inverse of plant available water is that managed allowable depletion.
Yes.
Okay. Okay, good to know. In your project, you were looking at different thresholds. So 25%, 50%, 75%. Any reason for choosing those, or is it just we're going to break this range into easily manageable, calculatable thresholds?
The idea was what we consider here is like most of the farmers, like how the growers use it is like they approximately use 50% amidi. So that's what we call like standard. We need to include that. And other than that, we also want to see like how low we can go and how high we can go. So we can have a range. And I think that's the main idea of incorporating these three things so that if we are achieving, that's only the scenario right now. So if we are achieving similar yield at 25% MAD, why farmers should irrigate like at 50% MAD? So we just want to create a frame and we want to include the higher and lower along with the what people are following now.
You also varied the amount of application per irrigation event, various measurements, whether half inch, three quarters of an inch. What was the hypothesis, I guess, in general about event size and timing?
What we think was like if we increase the amount of water that we apply plus per irrigation events will somehow affect the production, like it will increase the yield or there will be some difference at least between like zero point 0.5 inch and 0.75 inch, or there will be difference. That was one thing that we hypothesized. And if we consider threshold, we also think that threshold will also be affecting the yield and other quality parameters, as we also have other like parameters including disease and things that will also be affected by the threshold. What we thought was when we were applying like more amount of water per irrigation event or we were irrigating at a lower management allowable depletion, we thought that it will increase the crop yield, but it will at the same time affect how it affects the disease or things that we're investigating. So that was one hypothesis, while we have other thing that is soil compaction also in our trial, and it was we are seeing the interactive effect of soil compaction and irrigation. So what we thought was soil compaction will restrict the root growth and root zone soil moisture will deplete it more quickly. Therefore, like maximizing yield will require irrigating at lower management allowable depletion in compacted soils as compared to uncompacted soils. So yeah, this were the hypothesis and these were the things that we are thinking before starting the research.
And you mentioned compaction. That's the next place that I wanted to go. How did you create compacted versus uncompacted conditions in a way that's realistic to what you see on a farm, whether it's through, vehicle traffic or tillage or other things like that?
That's a very interesting question. We definitely could create compaction by just passing a heavy equipment. That doesn't make sense. But we want to be realistic with what the real scenario could be. So there are certain factors that we consider for creating the compaction. One of them was like passing the rototiller in compacted field when the soil moisture was higher. In year 2024, what we did was like there was a rainfall event, and just after 2 days of the rainfall, we passed the rototiller over the compacted plots, which was done in that year. And second year, we don't have the rainfall, but we try to simulate the rainfall using the water gun, and we passed the rototiller in the compacted plot. So that was one thing we did. Another thing that we did was in uncompacted plot, we passed the chisel plow so that it could break the hard pan, and it was done just before the final rototilling pass. This was not done in compacted plots. So this was the thing that we did it. And the thing is why we passed the rototiller at the point there was high moisture is that people usually enter in the field when their field is wet, which is not what we recommend, which should definitely increase the compaction, accessibility of soil to compaction. So yeah, this is how we ended up creating compaction in our field.
And one of my other questions with regard to compaction is there a concern for the difference between surface compaction versus subsurface compaction? Was that any of that taken into account in how you created these field conditions?
Surface compaction is basically the compaction that occurs at the surface, whereas subsurface are mostly due to the weight of equipments that are like too heavy and compacting the subsoil region of the soil. And I think the major difference for me is subsoil self compaction is something that is very difficult to get rid of, whereas surface compaction can be like passing something will definitely like help to break that hard pan. For our case, like potatoes need the rototilling at the end, which will reduce the subsurface compaction. but definitely there exists this subsurface compaction. For our case, I can say that we see this compaction starting at 9 inch of the soil, which we use different equipments, and the way there are ways we did it. So for our case, it's more about like subsurface compaction, which starts at 9 inches.
One last question for the study design. One of the fun things that I like hearing about is all the fun challenges that people have had in developing, especially in fieldwork. Fieldwork, and in a case like yours where you're trying to replicate a real world scenario. What was the hardest thing to create or mimic or control in a field trial like this one?
Like any research, I think like there are lots of challenges, limitations, and the broader goal of any project is ultimately making a meaningful connection with the grower community. And I think there are definitely some challenges. One of the things that is popping out in my mind right now is deciding which irrigation decision making approach to go on, because there are lots of like plant based, soil based, climate based methods, and each of them have their strength and limitation. So rather than relying on one particular method, we choose three different indicators. We use soil matrix potential, volumetric water content, and water balance based on the data that we obtain from the weather station. So I think like adding this three component instead of one help us to make more, we were more confident in our decision, and it increased the practical relevance of our result. Second thing is sensor placement. We were worried about like at what depth we should put the sensors that would be more reflective, that would more reflect the effective root zone. That is the thing we worried about. And the third thing that is coming to my mind is the mode of irrigation. If we use another mode of irrigation that people don't relate, they will not understand, they will not relate to our results also. So, and at the same point, we have 10 different irrigation treatments and we need to irrigate at different time frame. So for that, we choose the sprinkler irrigation, which could be relevant to the growers. At the same time, it will help us to like manage each plot separately because we were irrigating different treatments at different time. Another concern was the rainfall I told you earlier. We didn't have in 2025, but we have to simulate it on the basis of the moisture data we have earlier, and we try to simulate it. So these are the challenges. Some challenges definitely are those we have already seen in the future, which will come in the future, and we have worked on that. Whereas other challenges come instantly. It is also one of the character which researchers should have. Like they should be, they should able to like detect it at any point. Yeah, I think these are the things that are coming into my mind and till now.
At the beginning of that answer there, some of the sensors and other things that you've used. I'd love to dig into your measurement methods and other things. This is, after all, a podcast titled We Measure the World. So your thresholds were based on soil water release curves. And so I'd just like for you to walk us through how you built those curves, and then we're able to turn them into some kind of actionable irrigation trigger point.
The idea was like we need to know what is the soil matrix potential and volumetric water content at that depletion points. So we basically collected cores in both the years, the intact cores, and we run those through high probe and WP4C. By that, we could know, okay, at 25% management allowable depletion means like it's around minus 72 kPa. It helps to give us that idea. Along with that, it helps us to give it the moisture volumetric water content at that particular frame. And we used to see those data, and we have sensors, of course, and we used to see those data and see the threshold and volumetric water content every day and see, okay, this plot has dropped below the threshold we need, and we irrigate. So this is how we use soil moisture release curve and how we run the samples through high probe and WK4C and ultimately get what we need.
And you were also saying that you measured both matrix potential and volumetric water content. Which sensors were you using for those? And again, this is something that we talk about all the time here at Meter is why would you want to use both of those in conjunction as opposed to just one or the other?
For soil matrix potential, we use Terus 21, and if I remember it correct, we have around 40 Terus 21 in our field. And beside this, we also have Terus 10, which is we use for volumetric water content, and I think we have around 20 around the field. And the thing is that we want to use this both so that we could be the result that we obtain would be more relevant, and it could be relevant to the growers and things. And while using it, we place it at the depth of 6 inch, and we were monitoring those every day.
Your primary concern with using the matrix potential and the volumetric water content sensors was being able to have these different measurements so that the application could be broader when, say, for instance, you have individuals who are using volumetric water content. They could look at your research and say, I'm using volumetric water content. This is where I can pull that from, versus I'm using matrix potential. Did you see any usefulness in actuality in being able to use those in conjunction? A lot of times we talk about being able to generate your local in-field water retention curves or water release curves using both the matrix potential and the volumetric water content. Were you using those to generate any kind of field curves versus, you mentioned in the lab, you're using the HyProp and WP4C to create curves in the lab?
The idea of using like volumetric potential and volumetric water content, along with we also have the water balance, which I mentioned earlier, is that sometimes there exists variability between three of them, and we try to find out the point where at least two agree at the point that we need to irrigate. So basically, the idea is the variability that exists sometimes between three of the methods. We just want to make sure at least two of them agree in a point where we need to irrigate. So that I think that's the better I think wording how we can say why we use those three methods.
Got it. I wanted to ask about sensor placement as well. So you mentioned you place them about 6 inches below the ground surface. That's basically kind of where you would estimate the effective root zone. Is that correct?
We place the sensor exactly like 6 inch below the seed piece. And the idea of putting it was like we thought that it could be a zone where we have like roots, and putting that make more relevance to the irrigation decision approach. And according to the data that we have for roots, we find that about 88% of our roots lies in 9 inches below the seed piece. There might be still like confusion about whether we did right thing or not at placing at that sensor. But however, the way we have seen our roots data, I think it's like somehow relevant to put sensor in that depth.
How did you deal with, I think you mentioned this a little bit ago about field variability. How did you handle field variability with sensor placement? Anywhere you go, even a nicely plowed, nice and flat field is going to have variability below the surface. So how did you manage or mitigate those kinds of potential issues?
Okay, actually, we have like 5 replications in our trial, and thing is that we put the sensors in 2 of our replication so that we could average those, which will help us to like encounter the variability that exists in the field. It would be great if we could put the sensor in all 5 of the replications, but there are definitely limitations. So basically, we try to put the sensors in 2 of the replication and average those values before making any decision related to irrigation.
You also used a compaction meter or penetrometer. What does penetration resistance really mean biologically for the roots when it comes to, subsurface compaction?
Pentimeter resistance is something like it shows how it is difficult, how much it's difficult for anything to go down into the soil. It's basically trying to understand that. It generally have like a big needle, which is inserted into the soil, and it records the force that is required to push the pentimeter down into the soil. How it relates to the biological condition is we are trying to relate it with how it's difficult for roots to go deeper into the compaction. So I think it's more resembling the resistance that root face while going down. So it's understanding the mechanical resistance.
With potatoes in general as well, you said their root system is relatively shallow compared to other plant systems. What does a highly compacted or relatively compacted subsurface soil structure mean for roots? What are the potential results in roots struggling to penetrate down deeper into the soil?
That's a very interesting question. What is thought that it always says that like root is soil, potato is a crop which is has shallow root systems. And the thing that I have told earlier, like what we have seen through our results is that 80% of the root, about 88% of the roots lies in 9 inches below the seed base, and we have taken the soil sample down below the 24 inch. We also see the roots there also. So there exist roots of potatoes for sure. Some roots go down to there even. And We definitely compared the root biomass between compacted and uncompacted plot, but surprisingly, contrary to our hypothesis, we didn't see difference between compacted and uncompacted plots. And the thing is that there might be the causes, like because the question is will we be able to like create compaction uniform all over the field or not? Imagine you have cracks, cervixes like cracks in the layer, which help the roots to go down, even it's compacted. So that might be the point. But according to literature, if we go to the literature, it is seen that like around 2 to 3 MPa, the roots of potatoes starts to get disturbed in terms of penetrating down.
All right, let's move on to the fun part and the results of all of your hard work. So you have multiple years of research there at these plots. What were some of the primary results that you found? Were there any surprises in the data you're getting back?
So far, we have analyzed some of our data and some of our still going on process. Definitely, there are something interesting and something that we never expected. For instance, when we were increasing the amount of water that we apply at each irrigation events, it doesn't really translate into higher yield, which was surprising and definitely caught our attention. The thing is that increasing the amount of water doesn't necessarily improve yield, which was suggesting us that there is an option where we could save water without sacrificing productivity. The place where we saw a clear shift was when soil was allowed to dry for a longer period of time. We saw that like irrigating at 75% depletion reduced yield by approximately 14% in both the year as compared to 25% depletion. Interestingly, there was no difference in yield between 25% and 50% AMID, which was also help us reflect, okay, it is to gain the maximum yield, you can irrigate at 50% AMID or sooner. Another interesting thing that we come across was compaction. In 2024, we found that compaction was reducing the yield by 7% as compared to uncompacted plots. But in 2025, we didn't see such effects, so which was really surprising for us. And now we are also like moving forward with our data and we are seeing some trade-offs. For instance, the total weight of root potatoes. We found in 2024 that if we are irrigating more frequently, the size of the total amount, the total weight of the root potatoes were increasing, but we didn't observe that in 2025. Other than that, we have also some data related to common scab incidents. And interestingly, it is something to be considered. Whereas we found like if we are irrigating 0.5 inch of water, the common scab incidence was increasing. So some trade-offs definitely exist. One other important point that I think I should point out is that we found that in some of the treatments, compaction was limiting the amount of water plant could assess. I would again highlight the word that we found it only in few treatments, not in all treatments. We found, I think, in one treatment out of 10 in year 2024, and in 2025, we found it in 3 of the treatments out of 10. So these are definitely some of the interesting results, and there are many more to come. And I believe we will have more clearer picture by the end of this year.
I just want to dig into some of these results and see if you have any thoughts and explanations as to why you're seeing what you're seeing. One of your results there is showing that the amount of water per irrigation event didn't significantly affect the total yield, but then the timing and the threshold did. Am I on the right path there? What do you think is going on there? What do you think is happening there?
For threshold, I think like there is a more clear picture where it's ultimately showing like if you are drying it more, if the soil is dry for a longer period of time, the yield is decreased. So I think that's like somehow clear, but in amount, definitely there is something we are still working on. And if you ask my perspective now, I can't be saying, okay, that's the reason, but if that's my perspective is like, is it that zero 0.5 inch of water is something that is actually relating to yield and other water is lost in terms of evaporation or something that is going down to the groundwater, like it is drained out and only the 0.5 of inch of water is something that is plant is taking it and it is converting into yield and other things are lost in terms of evaporation or in terms of drainage. That might be the case, but that's only my thought till now and we are still figuring out and definitely will come up with something.
Interesting. And you also saw little to no yield difference between irrigating at the 25% and 50% depletion but then there's a drop, a clear drop at like about 75%. Is there some kind of physiological story to that, why things are looking good at the 25 and 50, and then there's a relatively extreme drop at 75%?
What my thought is that 75% depletion is the point, which is very close to permanent wilting point. And if we allow it to dry to that extent, there will be days where plant will not be able to get the amount of water it needs or amount of water it transpire. That's only the thing I can say till now.
And in terms of compaction, there was also a result that compaction reduced yield in 1 year, but not the other one. Do you have any kind of explanations? Is this just weather related? Is there something else going on?
I don't think like it is not definitely not related to the precipitation that we have difference, because ultimately we are controlling the environment. We are controlling the amount of water we are applying. We are controlling the threshold. It's still a mystery for us why we see the effect. But one thing that we consider is what that can be the case is in year 2025, there might be some differences in terms of like rototilling and in terms of the way we created the compaction. That could be one case because in 2025, there was rainfall after the first rototill, due to which even when the time we were rototilling the uncompacted plot, the moisture could be higher as compared to 2024. That's our in third till now. And definitely we have to think it a lot. And this result definitely show that there is a place where further research is needed to understand how soil compaction, at what conditions soil compaction mostly affect potato yield, quality, and soil moisture availability.
Really quickly, I wondered again, because you mentioned some of the other quality metrics or things that you were looking for. I mean, because potato growers don't just grow to sell yield, they're also looking for quality as well, right?
Yeah.
So could you go into a little bit, I guess, some of the implications about what you were finding for not just improving yield, but also potentially improving quality, or at least trying to avoid, some like soft rot and other things like that?
We are trying also to look like the size distribution of tubers, because they definitely is the thing that affect how much it costs or how much it will be beneficial for the farmers. So we are basically trying to sort the tubers into 4 different categories. That is like less than 2 ounce, 2 to 4 ounce, 4 to 6 ounce, and greater than 6 ounce. That is one thing we are doing. Other than that, one of our research question is how timing and amount of irrigation affects skin set. So for that, the idea was we were thinking is like if we are applying more amount of water or less amount of water, there will be some changes in skin set. For that, we also measure like torque meter. Basically, it help us to measure the force that is required to smear the skin of potatoes. And we are also using visual ratings for that. In addition to that, we have other things like tuber set, tuber count, which might be interesting for some of the farmers. So I think these are the things that we are considering other than that direct yield. And on the disease side, we are assessing the incidence and severity of common scab, which I told you earlier, which is the common scab is something that affect the appearance of tuber, which ultimately might reduce the value of tubers for the growers, which is very important. So we looked at and soft rod, because if you have lots of rods, it ultimately is like reducing your total yield. So these are the things that we are considering.
Did you see any particular thresholds, whether it's through irrigation timing or amounts or other things like that, where you would suggest and recommend? And we'll talk about applications and implications here in a little bit, but any kind of thresholds there where you would recommend to growers to avoid these, whether it's 25% managed depletion or other things like that, to avoid quality issues?
If I could say till now, by seeing the results till now, I think like 75% is something that will affect your yield, will not be good for your qualities, like good not for the even for the quality perspective. But for like other things, even I told you earlier, like common scab and software, we are still looking for it. And the thing is that I think some things we have the results, but definitely a economic analysis, which could give us a clear version, like clear vision of what is going on. And we have Dr. Suzette, who is in the project. She is the economist and she is working on looking at the cost benefit of this trade offs. And I think that economic analysis is something that should become before I give any suggestions for these things right now.
Okay. All right. I was going to say, I mean, as we get into applications, if a grower asked you, again with these preliminary findings right now, if a grower asked you, like, what is the simplest change that I can make next season to increase my yield and quality, what might you say based on your results so far?
So far, I'm still saying it's not something that I would recommend at this point. But if the scenario is like that, I would definitely say that 50% MAD is something that's good. And because in 25 we have a like higher rod, and we want to see how it's affecting the economics. So I think like 50% MAD, and for soil moisture, like amount of water applied, people I think like mostly use 1 inch, but I think like going to down to 0.75 inch won't be doing much big differences. That would be my thought. And I again say it's not my recommendation till now. We have to look for the economics.
And with that recommendation, and this is what your results were saying, yes, that maximizing yield, I wouldn't say requires, but you'd need to irrigate somewhere around 50% MAD or sooner. How close is that to the current practice in the region from what you're seeing with growers there?
I think like 50% is something I think most growers use. That's my thought. And for assessing this, we have planned this coming field season to install sensor in the commercial fields so that we could know actually when they irrigate. So I think this is something that's like a next step, and which also help us to understand how irrigation is going on, because most of the there are, I think I read somewhere like only 22% of the farmers in US, growers in US use scientific method for irrigation. So people are not very used to it. It's our duty to understand how they are irrigating. So I think that's something we are trying to do in next coming field season, and that will give us more idea.
On the flip side as well, with compaction. So if compaction can restrict water access under certain circumstances, what are the best prevention or mitigation? What are some of the best prevention or mitigation methods that they can use in their fields?
One thing that I would definitely say is that don't enter the field just after the rainfall, because it is the point like when the water is very close to fill capacity, which usually is achieved when just after 2 or 3 days of the rainfall, depending upon the soil texture. At that point, it's very fragile, and it's like the point where the soil is more susceptible to compaction. That would be one thing. And definitely there are some system like potato, in case we need potatoes, but it is a very intensive practice which ultimately like deteriorates your soil. It's like this is something that we needed, but it is also damaging and deteriorating the soil structure for sure. A proper crop rotation where you can manage those damages through other incorporation of other things would be something that could help to elevate this soil compaction, I think.
One other little side question. You were working with red potatoes, fresh market red
Yeah.
potatoes. How confident are you that these insights might be applicable to other varieties of potatoes or even other specialty crops?
This results, I think it was more relevant to potatoes, because the way we cultivate potatoes is very, I think it is distinct from other crops, and it could be applicable to some of the row crops, but the structure that we have in potatoes, the root system, how it is here, I think it is more relevant for potatoes. And in terms of varieties, I have seen some literatures where there is difference in terms of variety also, but I think it's more relevant within the varieties, but between the crops I think the scenario could be different. And other important thing that should be considered is the soil type. Other than that, varieties and other crops, the most important is soil type. We have a silty loam soil here, and if your soil is clay, it won't be the case, because the threshold we have here, the soil matrix potential, the threshold we have here is, it is completely different in case of other types of soil. So the thing will only that I would consider while I recommend is what is your soil type, because results very much differs. On basis of that, the amount of water we apply here might be different for other case depending on the soil types.
And we're getting close to the end here. I got a couple extra questions regarding collaboration. So at the beginning, we talked about who are your key collaborators. What are some of the, I mean, because this isn't just, you're not just doing research. This is kind of, extension and adoption. And so what are your plans for making all of your findings available to the actual growers? And how are you planning on communicating the final conclusions and research to those individuals?
Before like starting the research, there were like roadmaps program where we connected with farmers to understand what they want to see. I think that's from starting point we are very able to connect with the growers. And even now we are, as I told you earlier, we are trying to put some sensors in their field. And I think that is one of the point we are actually trying to communicate. And another thing was we were also looking for opportunities where we could actually do some things that we find here in some of the field. But I don't know to what extent we could possibly do that. Other than that, we usually attend conference. Like last December, I went to LinkedIn Expo, where it is especially the conference for the growers, and we presented. My PI presented, and I presented the poster. He have a whole presentation where we directly communicate with growers, and many were interested for our results. And yeah, these are the things that we have taught think till now, and there are other options like extension seats and stuff. But for now, we are looking to these things that I mentioned earlier.
So if we check back in a few years, what kinds of measurable outcomes would make you say that your grant succeeded or the project that you're working on was a success?
First thing is like connected to growers for sure, because we are doing things that could be more relatable to growers. And if we see people practicing it, that will be the biggest achievement. And other than that, I believe every research has some answers, but definitely there are like number of hidden questions that come across the research. And looking ahead, for instance, the compaction effect on yield and things, we would definitely love to see what are the factors that are responsible for those changes or those things. And along with that, this year we also took the soil samples from the compacted and uncompacted plots from the top of the hill. So basically the area that we already rototill, and the difference in compaction starts at only at 9 inches below the seed base. And the thing is that we saw that there was no significant difference in volumetry water content across the soil moisture release curve, which definitely is something we expected. But along with that, there is some question arising that so how rototilling is interacting with soil compaction. So that's something that has been popped off now. Along with that, we have some images of canopy cover, and I believe that will also bring an interesting area to our study where it will reveal the things about canopy cover, how it responded towards different level of compaction and irrigation. And yeah, these are the things that we are looking forward. And if we come to a point where we have an economic analysis of all the things, and we can directly recommend growers to use this irrigation mode or use that. So I think that point is something where I think our research is success.
That was my next question. And one of the things I'd like to ask our guests, like if your grant was, 10 times its size, what kinds of extra measurements or sensors would you like to do, remote sensing or root imaging or multiple sensor depths? What other parameters or variables would you like to look at, whether it's like, compaction timing or soil texture variability or different things like that? Any thoughts on if you could snap your fingers and get your wish, what would you like to have added to this project?
If I have like huge funding and things, one thing starting thing will be like adding sensors for sure. We would definitely love to have sensors in our all five replication and making this agriculture like irrigation decision on based on that. That will be one thing. And second thing is definitely what you have said, root biomass. Now we are only assessing the root biomass by the method of washing it and like getting the dry weight. If you can have like image analysis and see, definitely there is something interesting going in the roots. And according to my PI, who was here last year also in 2024, he could feel that those plants are the plants that are grown in compacted area, and these are the plants that are grown in uncompacted. So something is definitely going there, and we would love to see that. And I think going to roots through image analysis, that will be interesting. Another thing is that if I could have like a full survey over the Washington state to see how people's soil are compacted. I was reading a paper which was of, I don't know, like the European countries. They have a survey of 600 across farms where they were seeing how compacted their soil was. So if I have funding to go all across the Washington and see how compacted the soils are in potato field, at what time they irrigate, if I could learn that, if I could do that, I think we would be happier most.
Excellent. So, final question. What does the future hold for this particular project and for your research as an academic going forward?
Okay, this is my like second year of my master's, so I'm still learning a lot of things. It's my beginning of the career, beginning of the journey. By involving in soil physics, water management, and interaction with crops like potatoes, because potato is one of the major cash crop in my home country also. So it's like I definitely want to work ahead in this particular field where I want to be exploring soil physics. I want to explore how soil water plant interacts, going more deeper into the area. And probably I want to continue my academics, starting and looking for my PhD where I could work in similar field and expand my knowledge for sure, because it's like my first year working in it. And if I see me as a researcher, I think it is the area where I can invest a lot of my time without feeling bored, without feeling that I misuse my time or something. And definitely there are like lots of interesting facts that I need to explore. And there are lots of understanding which has already been understood by people, but I need to explore that even more. So yeah, I see my future. I see myself as I want to see myself as a researcher who is working in this field and loving the work she do, and hopefully doing something more interesting podcast in the futures with middle group.
Excellent. We would love that.
Yeah.
Any final thoughts for our audience?
Definitely we will love to engage with people who are working in similar fields. So if there are any people who are interested to connect us, please feel happy and feel free to connect to us and our PI, or me or my PI, who is Dr. Gabriel Lehiu. He's associate professor at Washington State. Please mail us. We would love to see what you think.
Beautiful. All right. Well, our time is up for today. Thank you again, Isha, for being here. We really appreciate you taking the time to talk with us today. It's been a very interesting discussion and conversation.
Yeah, thank you once again for inviting me and listening to my thoughts and listening to our research and our findings.
And if you in the audience have any questions about this topic or want to hear more, feel free to contact us at metergroup.com or reach out to us on X at meter_ENV. And you can also view the full transcript from today in the podcast description. That's all for now, and we'll catch you next time on We Measure the World.